Welcome back, students. Now with that understanding of redox reaction chapter of the previous parts, now it will be very easy for you to solve JEE question as well, which obviously you will see. So I will do solve it in this part, but it would be better if you solve it yourself first, okay? Just before looking into the solution. So here we go for the JEE question round, JEE question part. Hi students, so now we'll discuss some of the JEE questions so that your confidence level will get totally boosted up. It will get totally boosted up so that you will feel enjoy whenever you will get a question based upon redox reactions. So here we go. This is the first question, guys. So consider following reaction: X MnO4 plus Y C2O4 negative plus Z H plus gives you X Mn2 plus 2 times Y CO2 plus Z by 2 times of H2O. Now you have to find the value of X, Y and Z. This question has already come in JEE 2013. Now how I will move on to solve this question? Obviously I have to apply the fundas of balancing the chemical reaction, redox reaction, which I have taught you guys. So just you have to check the oxidation number state and oxidation state, and you have to analyze what is the difference. So if you will just, if I suppose write this equation as MnO4 negative plus C2O4 2 negative plus H plus, so this gives me my Mn2 plus CO2 plus H2O. Now you just check out here from 7 it is changing to 2, right? So what will be the change here? My Vf will be equal to 1 times of the charge 1, 7 minus 2, and here the coefficient it would be like Vf will be equal to 2 times of 3 minus 2, because here it's 3, here it should be 2. So if you check the corresponding stoichiometric coefficient, they will be exchanged, and so the equation which I will be getting here, the coefficient of C2O4 will be 5 and this one will be 2, right? So my equation will be like this: twice of MnO4 negative plus 5 times of C2O4 2 negative plus 10 times of H plus. This will give me twice of Mn2 plus 10 times of CO2 plus 8 times of H2O. So from here you can just check it out that your X value is equal to 2, Y value is equal to 5. So here if you balance it, so it will come out to be 16, okay, not 10, yeah, it will come out to be 16, and Z value will be equal to 16. So the answer will be X is equal to 2, Y is equal to 5 and Z is equal to 16. So I think the answer, the correct answer for this is your B part. So your B part is the correct answer for this, guys. So you have to calculate just the change in oxidation number and just multiply it with the cross stoichiometric coefficient here. This was the trick here. Let's move on to the next question, guys. So question is that amount of oxalic acid present in a solution can be determined by its titration with KMnO4 in the presence of H2SO4. Now this titration gives unsatisfactory result if I am taking HCl. So what is the reason? Now here what was happening earlier when I was taking H2SO4, so this was giving me totally my Mn2 plus, but the change was not with the reduction, okay? But whenever you take HCl here, so what you will observe that your MnO4, okay, MnO4 2 negative, plus your H plus ions coming from the HCl will require 5 electron also. This is the balanced chemical reaction I'm writing, okay, 8 here. So this will give you Mn2 plus 4H2. Now this is the reduction of your K2MnO4 to Mn2 plus, right? So it is actually reduction of permanganate into Mn2 plus. So let's see what is the option. Yes, C is the correct option then, because in case of HCl you can see that it is getting reduced into Mn2 plus, the permanganate thing. So C is the correct answer for this. Next question we move on to the titration of potassium dichromate solution with acidified more salt using diphenylamine as the indicator. So you have to calculate the number of moles of more salt which is required per mole of dichromate. So in these type of question, what you guys have to do, you have to just follow the equivalent weight method. Now what do I mean by that? I mean by that, suppose what is the n factor of my dichromate, n factor of my dichromate, this would be 6, and my more salt that is 1. Now 1 mole of dichromate, that will be equal to 6 equivalent of dichromate, that will be equal to 6 equivalent of dichromate by this relation, because your n factor for dichromate is 6. So this implies you have to, as given the question, it is getting titration against it, so you have to take 6 equivalent of more salt. This is my required thing, okay? This one is required. Now, since the n factor of my more salt is equal to 1, it is equal to 1. So this implies your 6 equivalent is equal to 6 moles. 6 equivalent is equal to 6 moles. And that's why your 1 mole of the dichromate will oxidize 6 moles of more salt. 6 moles of more salt. So this question was solved according to the basic fundas of what equivalent weight is. So the answer would be 6. Here is your answer. So D is the correct answer for this. D is the correct answer for this, guys. Let's move on to the next question. Is white phosphorus on reaction with NaOH, it gives pH3 as one of the product. So this is which kind of reaction? It is a very simple question here. So I will write the reaction here. If P4, which is my white phosphorus, getting added with my NaOH, so this will give me sodium hypophosphate. So that is your NaH2PO2 plus pH3. This is your phosgene, right? Which is written here that pH3 is one of the product. So if you balance it, it will be 3, and here also I will be adding 3 plus 3 here H2O. This is the complete balance reaction. Now here you can see that here the oxidation number is 0, and if you check out in this as well as this, so in one of the cases it will be more than 0, and one of the cases it will be less than 0. So that's why here the same product, same compound is getting reduced also and is getting oxidized also. Is getting reduced also, is getting oxidized also. So that's why, no, one second, just wait. It will be reduced in the above case, which I have drawn. Yeah, so here it is getting reduced and here it is getting oxidized. So that's why whenever my same component gets simultaneously oxidized and reduced, what is that type of reaction? That type of reaction is known as what? My disproportionation reaction. Disproportionation reaction. So that's why B will be the correct answer for this, guys. B will be the correct answer for this. Here is our last question, guys. Reduction of metal center in aqueous permanganate ion does not involve what? Now, you must be knowing that what it involves. Obviously, it involves 3 electron in my neutral medium, 3 electron in my alkaline medium, and 5 electron in my acidic medium. So, obviously, for this, the correct answer will be B. In neutral medium, I have 3 electrons for the metal center. So, the correct answer for this will be B part. So that's all, guys, for JEE question round. I hope you must have got the confidence now to solve these type of questions based upon the redox reactions. If you have any doubts in this chapter, you can log on to www.askIITians.com. There you can go to our discussion board and you can post your question by choosing your category. You have to select your category and you can post your question here. We experts at Ask IITians will answer to your question or doubts within 24 to 48 hours. Hi guys, so I hope you must have enjoyed this question round of JEE and you must have got the feeling that JEE questions are not very hard. Okay, they are very easy if you well learn the concept. So let's just revise everything whatever we have studied in redox reaction. I first told you, first of all, I introduced what is reduction, what is oxidation, what is a redox reaction. Then I told you about reducing agents and oxidizing agents. I also told you about 3 basic ways how do I define my oxidation and reduction. Then I told you about oxidation number concept, which is very useful concept. I also gave some examples by which we calculated the oxidation number. Okay, also oxidation number calculation depends upon the shapes also. Okay, make note of it. Then I told you about balancing of redox reaction. So there were 2 different ways, like half equation method and oxidation number method, in which I apply the fundas of oxidation number only, the application of oxidation number only to balance the charge actually, because balancing the number of atoms was like just simple chemical equation. But to balance the charge, we have to introduce the concept of oxidation number. Then I told you about equivalent weight, by which I can calculate my concentration terms. Also, I told you about law of equivalence. Then we move on to the redox titration. I explained what exactly is titration and what are the different types of titration. Also, then at the last, we saw electrochemical cells, how it is made up of, how my oxidation reduction half reactions are getting combined by a salt bridge and forming a redox reaction, okay, which is a spontaneous one. Also, we saw a whole chart of table of electrochemical series. So I hope by that time you have become so much confident in this chapter that you'll be feeling very happy if you get any question of it in your JEE exam or any competition exam or your board exam. So I hope you must have enjoyed this whole chapter. And for more videos, lectures of mathematics, physics, chemistry and biology, just log on to www.askiitians.com.